Chapter 7 Probability. At the end of the lesson, students should be able to differentiate between dependent and independent events, determine the probability of combined events for dependent and independent events. Probability of an event. Before we move on, let's look at the popular terms that are being used in probability. Okay, the first one is experiment. Experiment is a process to obtain the required result. An outcome, a possible result that can be obtained. Okay. A sample space, all the possible outcomes. So if you are doing one experiment and all the possible outcomes, okay, normally we will list out using set notation, and that set is known as sample space, and we use the capital S to denote sample space. Now the basic formula to find probability of event A is number of outcomes of event A over number of outcomes of sample space. Or you may simplify the formula as this: PA, meaning the probability of event A, equals to NA, meaning number of event A over number of sample space, NS. The range of the values of a probability lies between 0 and 1. So remember, the range of the values of a probability lies between 0 and 1. Okay, if PA equals to 1, then event A is sure to occur. If PA equals to 0, that means probability of an event A equals to 0, then event A will not occur. Probability of a complementary. In previous slide, we have seen how to find probability of an event A. That is number of event A over number of sample space. Now let's see how to find the probability of a complementary. That means other than A. The complementary of an event A is denoted by A prime. And the probability of a complementary event is given by 1 minus probability of event A. So you may write the formula as given here, that is P in bracket A prime, that means probability of complementary event A equals to 1 minus probability of event A. Now let's look at the example given. A box contains 20 cards. The cards are 21 to 40 respectively. If a card is chosen at random, find the probability of obtaining an even number. So what we can do is we can list out the sample space. So here you are given cards numbered from 21 until 40. So altogether the sample space you have 20 cards. Okay, so how to find the cards? You can also deduct 40 minus 21, then plus 1. You'll get the answer, or the number of sample space. Next, okay, the first event is getting even number. So the even number from the sample space, that will be 22, 24, 26 and so on until 40. So altogether the number of event A equals to 10. Now you may calculate the probability. That will be probability of event A equals to number of event A, that is 10, over number of sample space, that is 20. So simplify this, you get 1 over 2. Let's continue with question B, that is, find the probability of obtaining an odd number greater than 29. Okay, to start with, you can list out all the possible outcomes for the event B. So here a number, odd number greater than 29, that will be 31, 33, 35, 37 and 39. So number of event B equals to 5. Therefore, the probability of event B equals to 5 over 20 or equals to 1 over 4. Okay, let's move on to combined events. Okay, now the combined events are the combination of two or more events in an outcome. Okay, that means you have more than one. Okay, more than one events involved in the experiment. Okay, for example, the possible outcomes for two people playing rock, paper, scissors are, okay, let's list out all the possible outcomes. Okay, so here we have two outcomes. Since two people are playing, so the first people may be showing the sign scissor, the second one is showing paper. Okay, so the first outcome is scissor, paper, or it can be scissors and rock, rock, scissors, scissors and scissors, rock, paper, rock and rock, paper and rock, paper and scissors. Okay, so all together, okay, last one is paper and paper. So all together you have 9 outcomes. Now, if you still remember permutation, okay, in order to find the number of possible outcomes here, okay, since two people are playing, they can choose either rock, paper or scissors. That means we use the box method. Okay, so just imagine you have two boxes. Okay, so the first one can be filled with 3 options. That will be rock, paper or scissors. Now for the second box, again you can put in rock, paper or scissors. That means another 3. So 3 times 3. So altogether you have 9 possible outcomes. Okay. The combined events can result from one or more experiments. Okay, it can be from one experiment alone, okay, or it can be more than one experiment. So that is known as combined events. Okay, in general, number of sample space equals to number of event A times number of event B. As we did in the previous slide, we can use the box method to find the number of possible outcomes of event A and event B. Okay, now let's move on to another example. Write the sample space for the combined events below. 5 cards labeled with the letter T, E, K, U, N are put into a box. 2 cards are taken out at random from the box one by one without replacement. Okay, you can see the solution there. So these are the all possible outcomes. Okay, if you are not asked to list out all the possible outcomes and you just want to know how many possible outcomes, you may use the box method or permutation. So here, if you are using the box method, so you prepare 2 boxes. So for the first box, you can put in 5 options. Okay, since after one card is taken from the box, it is not being replaced into the box again, meaning that for the second box, you have only 4 options. So 5 times 4, you will get 20. Or another option, another way of getting the number of outcomes for the sample space. Okay, you can use permutation, that is 5 permuted 2. Okay, which you will get 20. Okay, next. Question B. 2 coins are tossed. Okay, T and H representing tails and heads respectively. Okay, so for the first coin, you have 2 possible outcomes. That will be T and H. For the second coin, also the same thing. You will have T and H. Okay, so here you can see all the possible outcomes that are being listed out. Or if you just want to know the number of the sample space, that will be 2 times 2 equals to 4. Dependent events and independent events. A combined event can be categorized as dependent events and independent events. Event A and event B are independent events if the occurrence of event A has no effect on the occurrence of event B. So please remember this. Independent events means the occurrence of event A has no effect on the occurrence of event B. In other words, event A and event B are dependent events if the occurrence of event A affects the occurrence of event B. Okay, in next slide we will see more example on this. Okay, let's look at an example here. Box P contains 5 cards labeled with the letters R, U, A and G. Okay, let's see the first case. Case 1. Okay, 2 cards are chosen at random from box P one by one without replacement. Write the probability of getting a consonant card on the first time and the second time. Now, if you study the question here, for the first time after getting the consonant card, we are not going to put back the card into the box. Therefore, for the second pick, for the second time when we want to pick a card, the number of cards will no longer the same as the first time. That means it has been reduced 1 card. Therefore, here the occurrence of the first event affect the occurrence of the second event. Therefore, this is an example of dependent events. Okay. Now, so in case 1, the first consonant card chosen is not returned to the box P. The short of this first consonant card affected the probability of selecting the second consonant card. Okay. Okay, now same example. Let's look at the second case. 2 cards are chosen at random from box P one by one with replacement. Okay, that means when we pick one card for the first time, we will return the card back to the box. Okay, therefore, for the second time, the number of cards will be the same. Okay, the letter for the first card is recorded and it is returned to the box P before the second card is chosen. So here, in case 2, the first consonant card chosen is returned to box P before the second card is chosen. The return of the first card results in the probability of selecting the second consonant card are being the same as the probability of selecting the first consonant card. Okay, so remember, when we return the first card and we are selecting the second consonant, the number of cards will be the same. Okay, therefore here the probability of selecting the second consonant card is not affected by the probability of selecting the first consonant card. Okay, so that here it is known as independent events. That means the occurrence of the first event does not affect the probability of the second event. Okay, let's see more example on this. Dependent and independent events. Identify whether the following combined events are dependent events or independent events. Justify your answer. Obtain a tail twice when a fair coin is tossed twice. Okay, so any guesses? Okay, now when you throw a coin for the first time, you can get tail or hit. And when you throw for the second time, again you will get tail or hit. Now, the occurrence of the first event here will not affect the occurrence of the second event. Therefore, you can conclude that this is an independent event. Okay, so here independent events, because the probability of getting a tail in the first toss does not affect the probability of getting a tail in the second toss. Now, obtain a tail in tossing a fair coin and obtain the number 4 in rolling a fair dice. Okay, so here the first one, you toss a fair coin, and then the other event is rolling a fair dice in order to get number 4. Okay, so it is also independent events because the probability of getting a tail in tossing a fair coin does not affect the probability of getting the number 4 in rolling a fair dice. Obtain 2 pens of the same color when 2 pens are taken out one by one from a container that contains 3 red pens and 2 blue pens without replacement. Okay, we are not going to replace the pen which have been already taken from the first pick. Okay, so here we want to obtain 2 pen of same color. Okay, so if you just imagine you pick the pen for the first time. Okay, now for the second time, since we are not going to replace the pen, for the second time the number of pens are not going to be the same as the first time. Okay, therefore the occurrence of the second event depends on the occurrence of the first event. Okay, therefore here it is dependent event. Okay, so here dependent events because the probability of getting the first red pen affects the probability of getting the second red pen. So as I said before, originally we have 3 red pens. If for the first time already one red pen is being taken out and is not being replaced into the box again, therefore the number of red pen for the second time will be less 1. That means no longer is the same as the first time. Therefore, the probability of the second event depends on the probability of the first event. Therefore, it is dependent event. Now, obtain 2 cards with the same letters. When 2 cards are chosen at random from the cards labeled with the letter BAIK one by one with replacement. See the word with replacement. That means when you pick one card for the first time and then you put back the card into the box and then choose the second card. That means for the second time the box contains the same number of cards. Therefore, the occurrence of the second event is not affected by the occurrence of the first event. Therefore, this is an independent event. Okay, independent events because the probability of choosing the first card does not affect the probability of choosing the second card. So I hope you can differentiate the dependent events and independent events. Okay, probability of 2 independent events, A and B. Probability of event A and B equals to probability of event A times probability of event B. So when you have the word AND, then you multiply. Remember that. Okay, so here the given example, box A and box B contain cards labeled with the numbers 3, 5, 7, 9 and the letters X, Y, Z respectively. A card is chosen randomly from box A and box B respectively. Okay, so you can see box A got card 3, 5, 7, 9 and box B with cards labeled X, Y, Z. Calculate the probability of getting a factor of 9, and the letter Z. Okay, now here first you need to choose one card. So in order to get a factor of 9 that will be 3 and 9. Okay, so let's look at the solution. So probability getting a factor of 9 will be, okay, since we have card 3 and card 3, 9, we can choose card 3 or 9 in order to get a factor of 9. So 2 out of 4. So that is the probability. If you still remember the basic formula of finding probability of event A equals to number of event A over number of sample space. So number of event A here is 2. Why 2? Because you have the digit, in fact the factors of 9 here is 3 and 9. So we have 2 answers out of sample space 4. So 2 over 4, that is 1 over 2. And for the second pick, we are going to take the card from box B. So we want to choose letter Z. So here you have only 1 out of 3. So it is, the probability is 1 over 3. Now if you study the question, this is an independent event. Why independent event? Because the occurrence of the second event is not affected by the occurrence of the first event. Okay, so here the probability getting a factor of 9 and the letter Z equals to 2 over 4 times 1 over 3, that is 1 over 6. Remember, when you have the word and, you multiply. Okay, let's look at another example. A bag contains 8 green marbles and 1 red marble. 2 marbles are chosen at random, one by one, from the bag without replacement. Again, without replacement. Okay, the colors of the marbles are recorded. Calculate the probability that the second marble is red. Now, since the first marble is not being replaced or is not being put back into the bag, therefore, for the second pick, the number of marbles in the bag will be reduced 1. Okay, so here it is dependent events. Why dependent? Because the occurrence of the second event is being affected by the occurrence of the first event. So originally, for the first trial, first pick, the number of marbles will be 9 altogether. But for the second time, when we want to choose another one more marble, the number of marbles left inside the bag is only 8, because without replacement. Okay, the first marble is not being replaced into the bag. Okay, let's look at the solution. Okay, the first one, the second marble have to be red. Okay, the possible outcome, so that the second marble is red, that means the first one we must get green and the second one is red, since we have only one red here. Okay, so there is no other possible outcome. We cannot put the red as the first outcome followed by green. That will be wrong. Okay, because here they ask you to calculate the probability that the second marble is red. So the possible outcome can be written as GR. Okay, now let's calculate the probability. So here we have only one possible outcome. Okay, now in order to get the green marble, so green we have altogether 8 marbles over the number of marbles, that will be 9 for the first event. For the second event, now here it is one outcome, so you multiply with the second event. For the second event, we want red marble, so red we have only 1 and total marble left only 8 now, because we didn't replace the first marble back into the bag. Okay, so you calculate this and you will get the answer as 1 over 9. Okay, now for the second question, calculate the probability that both are green marbles, that means G. Now in order to choose G for the first time, altogether we have 8 out of 9 marbles. Okay, for the second pick, okay, since we didn't replace the first marble, therefore green left only 7. Originally 8. For the first pick, we have already chosen 1 green, left another 7 green marble. Over total now only left 8. So therefore it is 7 over 8. So you multiply this and you'll get the answer as 7 over 9. Okay, now after going through this video, I want you to complete quiz 1 probability.